Hi and welcome to this very fast answer to this question in ROS Answers. So this user asks how to represent in 2D in RVIZ a red ball. So he asks, I already have all the OpenCV code detecting the ball and so forth. And the only thing that he or she wants is to represent it in RVIZ. So represent that detection in RVIZ. So how can you do that? Well, you can do it in many ways. I'm going to show you just the way I found that it's faster. So the first thing I've done is create a simulation that makes blob tracking. In this case, I've used RDS to do it. And this is a simulation of a very small robot that, if you can see it, it's basically two eyes, and in the middle it has a camera, and it just moves around only the head. And it's making blob tracking of this red ball here. So basically, more or less what this user is doing. So what we want now is, how do I represent the detection of the ball? So first of all, how am I detecting the ball? So what I'm doing is, I have this ROS topic, let me see, echo -1, so that's a blob. So I have these detections, and what I'm detecting is basically, I'm detecting a color that I've named red ball, and that has these values, has this blob area, and has this X and Y position in the camera. So let's say if the camera sees more or less this square, then where is positioned. So we can see exactly what the camera is seeing. So I'm going to open the visual tools, and here you're seeing exactly the camera, what it's seeing, and you can see that it's doing blob tracking. So it's drawing a very simple box around the ball. So that's how it's detecting. So here, let me just show you again. So here, what I'm doing is I'm having this blob position, so 240 and 217, that is referenced by the number of pixels of the camera image. So in our case, the camera image has 400 pixels. So if you have a look, so basically it's more or less, if this is 400 by 400, so 400 in width and 400 in height, then more or less is around the center. So it would be 200 and 200, more or less, in X and Y. Yeah? So once explained more or less the simulation that we have, let's see how this is done, how we can represent that detection in RVIZ. So for that, I've already created, otherwise it would be too cumbersome and slow. I've created this red ball markers package, which essentially has only one dependency, which is ROS by. You can see it here. So it's a very, very simple package. You can do it without any problems. And what I've done is create this script folder, and inside it, I've created this red ball marker publisher, which is basically what you have to do to answer this question here. So let's go over it. So let's start from the beginning. So we initialize a node, and we initialize this class, which is called ball detector, and we start the loop. Let's see this ball detector class. So there we have it. So this ball detector, what it does is subscribe to the blobs that we've seen. That gives us the blobs detections. So that's it. We have the X, Y area and so forth. And then what we do is initialize another class that we'll talk about later, which is called marker basics, that it's just here defined. So, but let's concentrate first on this. So this one, this subscriber to blobs topic, has this callback, which is called red ball detect callback. And if we go here, we see that what we do is, okay, we see if we have some blob detected here, and we iterate along all the blobs that we detect, and we look for a name of a color, which in this case is called red ball, which is just the code name for those colors that match the ball that we have. And then we say, okay, I've detected this ball. Then what I'm doing is getting this object and getting the X and Y that we saw in here. So I'm repeating, but I think it's clearer if we see it again. So I'm getting this values. And you see we are getting already, because we have the ball just in front, we are getting red ball, the colors, and then the X and Y positions, and then other extra stuff for positioning it. But essentially what you need to position in 3D space is this, the area X, Y. But in this case, we only need this, X and Y. So we have this here, we get the X value and the Y value, and then we make some transformations just because the values are pixels, so it's 200. That doesn't make any sense in space, really. So what we're doing is we are centering it first, because as you can see here, 200 is from this corner. So it would be 200 from here and then 200 up. What happens? That the frame of the camera is should be around here centered. So this should be the 0, 0, and if it moves to the right, then we are adding up X values, and if we are going up, it should add Z values in this case. How do we know this? So I'm going to, here I have it. So I'm going to run RVIZ in another web shell that I've just opened, clicking here on the plus button. So there we have it. Then we have the RVIZ, and then I upload my configuration for this simulation, which is here. So we can see the mirror robot with all the frames that we have. So let's get rid of the robot model for a moment. So you see here that you have the camera link, which is the frame that we are basing all the data to, referencing to. You see that you have the X value, which is the red stick here, and then you have the Y value sticking out. And it's the Z value that is generating the picture, let's say. So X is okay, it's the same one, but the Z is different because in the image it's Y values, and here based on this frame is the Z value, so you have to have that, take into account that. Okay, So let's add again the robot here. Yeah, so once you have this clear, in your robot, you'll have to do more or less the same. You'll have to maybe change the X and Y to Z and I don't know, and X and so on. That depends on the robot. In our case, it only happens that Y corresponds to the Z values. So what I'm doing is basically centering it. That's why I'm subtracting half of the camera width and half of the camera height. And then I'm just dividing it by the same value, so the camera width total. I've done this just to more or less have values that make sense, because otherwise you have to convert pixels to space. So this is a very rudimentary solution. Of course, you'll have to do it in a more sophisticated way. So you'll have to calibrate and see exactly what to do, and also use the area to have the Z position, because as you see here, I'm only positioning it in 2D space. So the Y, I'm just hard coding a value here. In your case, if you want to do it in 3-dimensional space, you'll have to use the area variable. So here we have the blobs in my case. So I have X, Y, and area. So the area of the blob can give you an estimate of the depth. So what's the distance between the robot and the ball, more or less. But all this, you have to calibrate it some way. Yeah. In this case, I'm just showing you a basic, very basic way of putting a marker of it in 2D space of a blob detection. So once you have this, then you have the position X and Z, the Y, and then you update the marker. Yeah. Just a tiny note. So this, the camera width and height, we get it from this. Here you have it. So this function, which is called save camera values, which what it does is read my camera info topic and retrieve those two values and save them in variables of the class, so I can access them anytime. This way you can adapt your algorithm to any camera. Okay, so this is the way we retrieve the data and we process and we adjust for the differences in axis and in values, more or less, in units. And then we have this marker. So how do we do this? So you see that this marker basis object, we initialize this here, and it's basically this marker basics class. So let's go up a bit. There you have it. So marker basics is a class that initializes a publisher of type marker, which you extract from the package visualization messages.message, and then we initialize some variables like the rate, and we initialize the marker. So we initialize the first value of the marker. All the values, let's say the default, how, the shape, the size, the color, everything. So here you define a type marker, you define the frame ID, which is one of the most important things. So in this case, I'm using camera link. See, I'm using this one here, this one, the camera link, which is this tiny little dot here that we have. So if we disconnect this, you see there's a very tiny dot, which is the camera in this case, in this tiny robot. And then continuing, so we have stamp is also really important. Just get the time. Namespace, the one of the robot that you're using, is not very important. is just to divide. So if you have different markers, you can filter by the namespace, for example. This is important. The sphere, so the type, you can put spheres, you can put boxes, or you can put custom dies, so three-dimensional shapes. You can put anything you want. But in this case, we are just putting the sphere. It's faster and easier. And then you do the action of adding that marker. Okay, and then what we do is define the position. So in this case, the point, we initialize basic values, so nothing fancy. Just this is important because this defines the shape of the sphere, like how big it is. In this case, if you put 1, 1, 1, then it's 1 meter by 1 meter, which is humongous for this size of the robot and for the sphere. So more or less, I put more or less the similar shape and size as the real ball. You just have to adjust it. And then the color, so in this case it's red, so I put red here, so 1, 0, 0, and this is important to make it transparent or not. In this case you have to put 1 so that it's totally opaque. And then you put the lifetime of the marker. In this case I put duration 0, which means it stays forever and ever. Otherwise you have to keep publishing all the time to keep the marker from disappearing. Okay, and then we have this function which is called update position, which accesses this variable marker object and just updates the position. That's it. And then you publish it to this marker object, which is this one. Yeah, and that's quite it actually. So let's have a look how this works more or less. So we have our tiny little bot here, and we are going to let's put the robot more or less here. Yeah, there we go. Here, yeah. So now I'm going to start my script. So ROS run red ball markers, red ball marker publisher. Yeah. So let's start it. There we go. Okay, here we have the RVIZ, and here I'm going to mark the red ball. There we go. So as you can see, more or less, it's staying here. It's oscillating a bit just because the detections oscillate, so it's quite normal. Okay, so now what we're going to do is I'm going to divide the screen so we can see both. There we go. So I have a script to move the ball with the keyboard. Okay, so let's reduce the speed a bit. So if I move, the robot tries to track it, and as you can see, it more or less represents the movement, more or less. Of course, you have to calibrate it so that the distance is exactly the distance that you want. Otherwise, it can give problems, like it's giving right now, because we've just converted the units hard-coded, and it has to depend on the distance. So you'll have to get some way of calibrating and representing it in three-dimensional space. Otherwise, as you can see, very small fluctuations make it move a lot, when basically it's tracking and moving very slightly, but this movement affects also this. Okay, so there you go. So you have a 2D tracking of a ball represented in RVIZ. So if you like the video, please give us a thumbs up and think about subscribing if you want to know more about these kind of questions and answers about robotics and so on. And that's quite it. Thank you very much and hope to see you soon.